We're going to continue discussing problems in electrophilic aromatic substitution. So understanding how groups are activating or deactivating and where are they directing. But right now, I want to point out a few things about functional group interconversion. So in synthesis, we sometimes install a functional group and then we change it. And that can change the way they direct further synthesis. So let's give an example on that. Say that I'm doing, this is just benzene, and I'm performing a nitration. So nitric acid, sulfuric acid, and all right, I install a nitro group. Now, nitro, we know is deactivating, and as deactivating, it is meta directing. So we'll do any other group that I want to install will go into meta. But what if I now reduce that group to an amino group? And here what you do, if you wanted that, you can use zinc, for example, in hydrochloric acid. That will, and say that followed by base, and you will get the reduction of the nitro group to make aniline. So you have reduced that nitro to an amine. Now, the amino group, as remember that here we have a lone pair. And so it is an activator. It activates the aromatic ring towards further electrophilic aromatic substitution. And as such, is ortho-para director. So as you see, if I continue doing something from nitrobenzene, let's say that I'm doing, let's do a chlorination, for example, and I'm doing aluminum trichloride. If I do that, the nitro group is going to direct meta. It is deactivating meta director. So my product will be with chlorine meta, and I only have one product. Let's say that I try now this with aniline, so I have reduced that. How that change it? Well, now this group is activator and ortho-para directing, as we see here in the arrows. So the same reaction, I'm doing the chlorination. What's now the product? I have a mix of products. I'm going to have ortho and para chloroaniline. So see that exchange, the reduction of that functional group, change the way the group direct for the substitution. So we need to be aware of that. Let's give another example of that. Another reaction can be, for example, if we're using Friedel-Crafts acylation. Let's see one example of that. And now, okay, I'm going to say that here, that's, okay, my benzene, and I want to do this acid chloride, and I need my Lewis acid, so aluminum trichloride. What is it you're doing? A Friedel-Crafts acylation, and you will be installing this at the aromatic ring. So your product is going to be this. 1, 2, 3, 1, 2, 3. That. Now, this group, as it is right here, is electron withdrawing, so it will deactivate the aromatic ring. Remember here you have a dipole. So this is deactivating, and as such is meta directing. So if I do another substitution from here, the next substitution is gonna be in the meta position. But let's say that I'm performing, as I did in my previous example, a chlorination. So chlorine and aluminum trichloride as my Lewis acid. Now what's going to happen is going to be the substitution at the meta position. So here's my product. But now in many cases, we use the Friedel-Crafts acylation to install an alkyl group when there is a possibility of rearrangement. And when we do that, we continue after the Friedel-Crafts acylation, we need to do a reduction of the carbonyl. So when we do that, we use zinc and mercury, and that with hydrochloric acid and heat. And what it does, it will reduce this, and you will have 1, 2, 3, and 4. 1, 2, 3, and 4. And here you have installed a butyl group. Notice that if you did this directly with butyl chloride, that could, if you think of the forming a primary carbon-cation, is not stable at all. So you will have a 1,2 hydride shift. And so that's why we don't use this type of substrate for Friedel-Crafts alkylation directly, because it will rearrange. If this is your electrophile, your product is not going to be butylbenzene, but here this. So, yeah, so it is different, it is rearranged. So to avoid that, that's why we use the Friedel-Crafts acylation instead of the alkylation when you have the possibility. But what happens if we go this path? So this compound, again, the substituent is deactivating and is metal-directing. What happens if I do the reduction? How this group behaves now? That's an alkyl group. And alkyl groups are activating. So alkyl groups are activating towards another substitution, electrophilic aromatic substitution, and ortho para directing. So we see that after that reduction reaction, that it is directing differently. Now the product, we're going to have two products. If this is big, you're going to have the para as your major product. So we're going to have then 1, 2, 3, and 4. And let's say that we're doing same reaction. I'm going to do, I didn't write it, so same chlorination. And now the substituent will go ortho, let me do it on that side, and para. So you will have a different outcome, as you can see. After that you have interchanged the functional group. Again, you started installing that group and you have reduced it, it changed the way it directed. Same way it happened when we reduced the Nitro group. So those are things that we need to consider when we are doing synthesis problems.